Okay, good afternoon, everyone. Okay, 我听到讲你们的考试没有 moment 了是，剩下 projectile 还有gravity and also forces 啊。So 今天我们 revise projectile. Okay, yeah. By the way, I see there's unstable internet connection. So is the sound still okay? Testing, testing, 1, 2, 3. Testing 1, 2, 3. If it's okay, give me a thumbs up. I see a pop-up just now. It says that the internet is unstable, so we might experience a little bit of lagging. So yeah, but I'm recording this one, so in case you miss anything, you can go back and see. Okay, let's start now without further delay. Let's start. Project. Okay. Okay, now projectile motion. What is it? Okay, projectile is anything that you throw. Okay, that thing is called projectile. Okay, so projectile motion. Now, in the previous lesson, we learned about what? We learned about horizontal motion, right? Linear motion. Vertical motion also. These two are linear motion in a straight line. And also it involves only one component of velocity, meaning that only this one, only the x component, and this one, only the y component. So this is one-dimensional movement. Okay, horizontal and vertical motion, woman applies more. We apply the equation of motion, right? So V equals to U plus AT, or the four formulas. We are going to use the same for the projectile motion because in the end, we are still dealing with motions. Okay, let's first understand what is projectile motion. Now, a projectile is an object upon which the only force acting is gravity. Again, projectile is an object at which the only force acting on it is gravity. So if you think about this one, 意思说是在一个 motion 里面如果只有 gravity 是 acting on that object then that is a projectile motion. Is your horizontal motion projectile motion? Answer is no, right? Because it's going horizontal. The gravity is independent to the horizontal motion. It's acting downward. But your vertical, here, you throw a ball, go up. The moment it is up in the air, it is subjected to a gravitational acceleration of 10 downward, right? So at any point during the motion, it is being affected by the gravitational force. Is it only the gravitational force? Is there any other forces in the vertical motion? Answer is no, it is only the gravitational force, right? So your vertical motion is also a projectile motion. Here we are going to ignore the air resistance, okay? Only the gravitational forces. Now, but here we are not going to talk about the vertical. We are going to focus on a two-dimensional motion. For example, let's say I put a cannon at the top of a cliff. I put a cannon here, and then imagine I have something called the gravity switch, which I can switch off the gravity. Okay, now in all the examples, we are going to assume that there is no air resistance. Remember, okay? Now, when I turn off the gravity switch, then I shoot the cannonball. Okay, it's going in this direction, right? I shoot it horizontally. So I give it an initial velocity V here. And because there's no air resistance and there's no gravity, so what is the path of it will take? What is the path that it will take? It will continue to move straight like this, right? Like this and like this at a constant velocity. It will not stop until what? It will not stop until there is an unbalanced force acting on it. You learn about this. This is the inertia. Okay, so object will continue to do its thing. Okay, now what happened is that this is the trajectory it will take, right? Now, Let's say suddenly I switch on the gravity switch. Now there is a gravity acting on it. What happened is that the moment it comes out, there is a G acting on it, right? So how much is the G? 10. So every second, its velocity is increasing downward by 10. The next second, it has increased 20. The next second, it has increased 30. So it's going faster and faster downward. Okay, so this downward force of gravity, does it affect the horizontal motion? Answer is no. The vertical forces of the gravity will not affect the horizontal motion, meaning that the object will keep on moving to the right at whatever velocity that it is moving, but at the same time, it's going to have an extra velocity downward. So now he got two velocity, right? He got one to the right and one downward. Okay, so what will be the path of the object? It will curve downward like this. Okay, so it curves downward. It looks like a parabolic. Parabolic 就这样子 curve, a curved line like this. It's keep on increasing like this. This is a parabolic. Okay, so every second, here V increase, here V increase, here V increase, and then it will take this curve path downward. And this is the basis of projectile motion. Okay, and it is a two-dimensional motion. Why we say two-dimensional? 因为你有 V in the X direction, 还有你有 V in the Y direction. You got two V here. Okay. Similarly, I give you another example. Let's say this one. Now I point my cannonball at an angle upward. Okay. I shoot the ball. Same. I'm giving it an initial velocity. This initial velocity is maintained. Okay, V, because there's no air resistance. So when it is moving at constant V, constant V means what? Constant V means your acceleration is 0. And if you use F equals to ma, then your resultant force will be also 0. So there is no force acting on it. Now I turn on, okay, this is the path without the gravity, right? Same, I turn on the gravity switch right now. And what path it will take? Initially, it will go up and then it will start to curve downward like this. Okay, now during this first part, when it goes up, what happened to the velocity? Okay, you see, there is an acceleration downward. So the ball is moving upward, right? So if there's an acceleration downward and the ball is moving upward, what does it mean? Meaning that there is a deceleration. The velocity upward is decreasing, right? The velocity going up is decreasing, and then at some point along the motion, there will be 0 velocity upward. Okay, what velocity? Upward velocity. Okay, the upward velocity is 0, and then it will start to turn down and speed up at the bottom like this. So this is another projectile motion. What is the similarity in the two types of motion here, including the vertical? In all the cases, there's only one force affecting the object. That is the gravity. Okay, so if you argue, you say that, okay, no, there's a result. How come if it's only gravity, right? How come it will move to the right? Right? How come? Understand that force does not create motion. Okay. Force create acceleration. This is the one thing you have to make it very clear. Okay, so many students, they see when the object is moving here, meaning that there must be a force acting in this direction. No. Okay, you cannot look at it like this. Force create acceleration. So if the object is moving constant velocity, there's no acceleration, right? So is there any force pushing it? No force. It's a balanced force system. Okay, so resultant force is 0, but it is moving. Have to understand that. Okay, so object move here because of what then? Because of the inertia of the object, the ability of it to maintain its motion because it moves here. So overall, there's only one forces acting, It is the gravitational force, and that force creates a curving downward. That is projectile motion. Okay, now we understand already projectile motion. These three types, we got three types, right? Vertical first type, this one second, and this one third. What are the differences between all these three? Number one, it only goes up, down. Number two, initial, it goes horizontal and then curve. Number three, starting already curve and then curve down. That's the difference between these two. In this lesson, we are going to focus more on number two and number three, the two-dimensional motion. One already learned lah. Okay. Now 2 and 3. Okay, let's say here I've drawn a curve. Consider a typical projectile motion. Looks like this, and we start from point A. Okay, imagine I launch an object in this at an angle. Okay, at an angle to the horizontal. So I would write the axis, horizontal axis, that is parallel to the ground. This angle is, okay, I just put unknown angle, and then I launch it at this V. Okay, this V is in this direction. Okay, along the line, you can see along the trajectory. Now, if the object moves from point A and point B, let's say B is somewhere here. When the object moves from point A to point B, look at the position of the object. It has changed from here to here. So we say that this motion, right, has two displacement change. One is the vertical displacement, one is the horizontal displacement. Where is the horizontal displacement? From A to B, I can also say that the object is displaced this much to the right, this much. If I draw it, I will write Sx. X is displacement, right? So X is in the X direction. Okay, starting from here, this is how much it has moved horizontally. That's the horizontal displacement. At the same time, not only it is being displaced horizontally, it is also being displaced vertically. And this would be my X as Y. Okay, now, so there will be a displacement in both directions. Okay, imagine if I'm seeing from here. Okay, I want to introduce these two perspectives of looking at a projectile motion. Whenever you look at a projectile motion, right, you have to use two perspectives. One is the vertical component perspective, and then another one is the horizontal component. Okay, the best way to imagine this is like that. It's like this. Vertical, okay, let's talk about vertical first. Imagine vertical is like you're looking from the left here. Imagine that your line of sight is on the same plane as the trajectory of the projectile. Okay, so you're looking like as if you are the one throwing it. Okay, you throw it, you cannot, if you stand here, right, if you stand here and you're looking at the same plane, right, then you cannot see the curvature. You cannot see the curvature. What do you see? You see this thing like this. This is the object, and this is the launch point, right? This is point A. You see going up to point B. Okay, B is not the highest point, right? So maybe go higher a bit. Then it comes back down. This is what I see, only one line. Because my line of sight is parallel to the motion. I cannot see the curve, the rainbow. Only if a person standing at the side, you can see the curve. Okay, so this is one way of imagining the vertical component movement. This is the vertical component. Okay, horizontal component, same way. I imagine this time I am looking from the top, and my plane is the same as the plane of the trajectory. So if I'm looking from the top, how would the motion appear to me? It appear like this. From the left, okay, I'm looking from here, right? So it goes from left to right. Left, point A, it goes to the right, and whatever the point here, let's call this G, point G. Okay, so this is how it moves as seen from the top. Okay, I cannot see the vertical. Now, in any of this example, the other component is missing inside. Okay, it's missing inside. So to analyze projectile motion, you have to think of it like this, these two ways. This will make it easier for you. Whenever we are looking at the vertical component, you don't look at the horizontal component. Whenever we are looking at the horizontal component, you don't look at the vertical component. They have to be analyzed in isolation. What does that mean? 意思说你只是单单看 vertical 就 vertical 吧 ，horizontal 就 horizontal 吧。You don't mix here and mix there and then you become confused already. Okay? Now, understand so far what we have said. Understand that projectile motion got two components of motion. Okay? One is the horizontal, one is the vertical. Okay, even if this velocity, you see the velocity that you throw, 这个你丢的 velocity 是在这一个 direction 对吗？它是 along the line of the trajectory Now, 从 A 去这里这个 point, okay, let's call it point C, whatever lah. There is a horizontal movement. There is also a vertical movement. So I can draw my vector diagram. Go here from here, I can change it to go horizontal, and then I go up. In the end, I still reach the same place. It's the same result. It's just I divide it into two components. In other words, these two combine to get this one. Okay, so 这个是 v， 这样我就叫这个什么？这个 vx。This is vy. Now vx is only one portion of v, so it is always less than v in terms of the value, in terms of the magnitude. Vy is the same. It is one component of it, so it must be less than the v. If your v is 50, this single component cannot be 60. No, it is already larger than it. It has to be always smaller than it. Okay, because it is just one component of it. Okay, now here we have Vx and Vy, and this is our angle of launch, right? So to find the Vx, Vx would be equal to this one. You need to apply the right angle triangle. 这里是90度，对吗？90度 ，v 跟 x 跟 vy 是90度，然后我就用我的 sin cos tangent。Okay, so 差多啊。So Vx, if I find this, I resolve this, I can get V is actually equals to cos theta. Vy 呢 ？Vy 是 V sin theta. Okay, the one easy way to do this, if you remember in the last lesson I talked about this one, you put the vector in the Cartesian plane. 这个是你的 y， 这个是你的 x axis， 你的这个是那个 v vector。Okay, let me use the green color. Oops, wait. Okay, this is your V, right? Now, one way to resolve it is, imagine if you want to find the x component, you imagine you bring this down. Imagine 你把它拉下来， okay, 你拉下来，你拉下来的时候是它就去 parallel 跟那个 x axis， 这样你每次你move towards 那个 angle 的时候我们就是用 cos angle。然后你拉走去上面那一边你就 moving away from the angle, then this would be v sin theta. Okay, you get the same thing. Vy is v sin theta, Vx is v cos theta. Okay, now I have expressed this one in two components. Upward velocity. Okay, I draw it here, v sin theta. And here, this is v cos theta. Okay, now then, what happened during the motion? Okay, we look at how does the velocity changes during the motion. From point A to point B, and maybe to point D on top here, this is the tallest point, the tallest point. So I will write this as the maximum height, capital H, max height. Okay, A, B, let's say I put one more point here. 从 A 去 C 去 B 去 D 上到去它的最高点的时候，它的 vertical velocity component 会怎样变 ？Okay, you see at point C, velocity y 啊 vy 啊，就是 vertical component 的 velocity 啊，它是本来是向上的嘛，对不对？我丢它嘛，它有向上的嘛。当它一在 A 的时候，它就有 acceleration downward，因为那个 gravity，所以这个 vy 会慢慢减少。So this one will become shorter, vy, and this one also shorter. This one shorter than this. This is lower than this one, and eventually at point D, the vy is nothing already, it's zero already. So at here, vy is zero. This is a very, very important information you need to know. At the top, 你的 vertical component 是 zero velocity. Okay? Now, the velocity slow down because of the gravitational acceleration. Now, how about the horizontal velocity? 一来你丢的，你给它的那个 horizontal velocity v cos x， 这个会给影响吗？不会给影响。我们之前已经讲了咯，这边对吗？ Okay, it will continue to move to the right, assuming that there's no air resistance. So the velocity to the horizontal has no effect. It's not affected by the gravity. So it's the same at every point. 这里 v cos x 也是一样，这里也是一样，这里也是一样。在最上面的时候，它有 vertical velocity 吗？没有，它是零。它有 horizontal velocity 吗？有，是多少？是跟你一来的一样，因为它是没有变的 constant velocity. Okay, now after this one, what happened after the max height here? Then we put, okay, point D, point E, point F, point G. The vertical component of the velocity now is acting downward, right? Now it's acting downward. So this one would be downward, Vy. And at F, it is larger already. Now it starts to increase because of the acceleration downward. This one, Vy, bigger. And at the point close to the ground, it will have the maximum Vy. What is your Vx? Same. Vx, Vx, Vx. In any point along the projectile, your Vx is constant. That means your acceleration in the horizontal direction, Ax, 就是零，因为你的 velocity 没有变嘛，所以它是 zero acceleration. That is for the horizontal. The vertical, 10. Okay? So this proves what? This proves that the horizontal motion is independent of the vertical motion. Let me write this down. Horizontal motion is independent to the vertical motion. Okay, so what is a projectile? A projectile is an object upon which the only force acting is gravity. Okay, it can be one-dimensional movement. In that case would be the vertical motion only. It can be a two-dimensional movement, like a rainbow, like this. In a two-dimensional movement, you need to analyze it separately. Vertical, vertical, horizontal, horizontal. Okay. Next part. Okay, if you want to take a screenshot, you can take a screenshot first. And then I will go to the next part. Let me clear this bit, get some space. Okay. This is why I leave it like this, huh? Because later I will refer to this diagram. Okay, let's continue. All right. So now we understand the basis of projectile motions. And now we start to analyze. Okay, in analyzing the projectile motion, we are going to use the same formula, VUAT, V square, U square, 2AS, SU plus V over 2T, and S equals to UT. Okay, here let's consider midway. Considering, yeah, 这个 block 住我一下。Considering midway, meaning that it reaches the max height, okay, maximum height at the middle of the projectile. Okay, now what are the things that we can gather in terms of the informations? First, we can look at the vertical component. Look at the vertical component. Now, in the vertical component, what information can we get? 从 A 去到 D， 对吗？去中间，从 A 去到 D 啊 ，imagine 啊。Now A 去到 D，OK， 如果我们看 vertical 的话哦 ，what do you see? How it looks like? It's like this, right? From A, rise to the top. That's D. This is what you see if you take out the horizontal component. Okay, it's like you're seeing from the side. Okay, what is the initial velocity? 哪一个 V sine theta. Okay, that is the V sine theta. So I will write initial velocity. Okay, 我们用 U 啦 U sine theta. V is just a general term. Okay, we use U. Okay, now I get this U sine theta. And then what is the acceleration? I also got the acceleration, right? So A, Y, I will write acceleration in the vertical is equals to G, which is 10. And then what else? The maximum height at this height at point D, I know Vy is equals to 0. Okay, Vy is equals to 0. Now, let me change this first. This is Uy, initial velocity in the vertical component, right? Is U cos theta. Sorry, sine theta. Okay, so these are all the information that you can get. So it's a known value. This is a known value. This is a known value. This is known value. 你这全部这种你就可以算到了吗 ？Angle 给了你 ，initial velocity 给了你 ，OK， and then acceleration 也是10 ，Vy 是0，所以你已经有3个 information 了，这样你就可以算了。你可以算什么？从你的这个 equation， 我们可以用 VUAT U 加 AT。I can find the time. Okay, what is this time? The time is the time to reach the midway, the max height. Okay, using this, all these are given. I can also find using a second formula, v square u square 加 2as. 我也可以找我的 displacement， 这个就是我的 max height 了。Okay， 因为全部都是 vertical 来的嘛。Max height displacement s is measured from A to D here. Okay, that is for vertical component. Now, here I change to horizontal. If I analyze from the horizontal component, then what do I see? I see that it goes from A to where? To D first, right? To the midway, right? Midpoint. Okay, what is the initial velocity? This is U, now is cos theta. Okay, I'm not seeing the V anymore. I see the U cos theta. And what else you know about a horizontal component? You know that the A acceleration is 0 for the constant, for the horizontal component. Okay, and this, if acceleration is 0, then this U cos theta, the initial velocity is a constant throughout the journey. Okay, 我写下来 ax 等于0 ，ux 就是 u cos theta 啦 SX 就是你的 distance A 去 D， 也就是我们讲 mid range。 Okay, and then the time would be the time to reach the midpoint. And then using the formula S equals to UT plus half AT squared. 你的 A 你看啊，我用这个 formula 哦 for horizontal component 的时候是 horizontal component acceleration 是多少？0，对吗？意思说这个整个是0。我这个是 apply for horizontal 的 ，OK， 所以 don't ask why. Okay, why is the acceleration not 10? Why is it 0? Because I'm looking from the horizontal component. Where is the vertical? The vertical is the green one. This one I'm solving only for the horizontal. So that is why our acceleration is not 10, it's 0. Okay, make sense? Does that make sense? Okay, so this one is 0, then we have S equals to UT. 这个全部都是 horizontal 的嘛，对不对？ So S 是 SX 来的 ，U 是 UX。Now， 如果我知道 time， 这样我就可以找我的 SX。Time 从哪里拿？从你的 vertical 那边拿。你的 vertical 这里的 time 算到的是跟这个 time 一样的。为什么呢？因为它从 A 去到 D 的时候啊，它只有一个时间罢了嘛，对不对？它没有其他的时间，它就只有一个时间从 A 去到 D。如果它用4秒去那边，它就是用4秒。不管你是从上面看，你从左边看，全部你都是用4秒去那边嘛，对不对？ So 那个时间是一样的 ，regardless of vertical or horizontal. The time taken for it to move from this point to this point is the same. There's only one time. That's why we can use the time here. Okay, we can use the time here, and then we can find with the V, with the UX given, with the T value plug in, I can find SX. What is XX? SX is the distance to the middle, the horizontal distance. The horizontal distance to middle. Okay, so this is for looking at considering a midway. Then next one, we want to look at if we consider all of the solution, I mean all of the motion from all the way to point G. Okay, now here I write considering whole journey. Okay, before we continue from this one, I create another link and we continue from there. Okay, left 2 minutes.